Hey there, this is 6.2b on solving linear systems by substitution. Today we're going to look at finishing off this lesson that we started the Friday before the wave week. And so with this lesson, what we're going to look at is being able to continue looking at how to solve systems through substitution and also knowing how many solutions come out of a system. And then this falls under our two standards on systems, AREI 6 and 6A. And so a couple of definitions we need to know before we jump into the bulk of today's lesson. You'll see these terms highlighted in yellow, and these are terms that you need to have in the back of your head. Now, it's not the most important thing to know today, but it is important to know that these terms are out there and what they mean. Okay, and so when we talk about our three systems, our first system is our intersecting system, right? So our intersecting system is one where the two lines are graphed, and there will be one solution because when we graph them, they make intersecting lines. So I would have a line like this, and I would have a line like this, and the point of intersection is the point at where they cross. And that is one solution, which is written as an ordered pair, right? So whatever this point is, we write it as x, comma, y, right? So like 2, -5, whatever the point might be, okay? And so that's intersecting. And we call that consistent and independent. We call it consistent because it has a solution. We call it independent because the two lines do not depend on each other. I can have two different lines in the graph and they have nothing to do with one another, okay? The second type of system is same line. And so if I draw the lines, I'd have the first line, and then my second line would be the exact same line on top of it, right? And so this is called a consistent dependent system. It's consistent because there are solutions, but it is dependent because the two lines are dependent on each other, because all the solutions are everywhere where these two lines touch. And so the number of solutions is infinitely many, because how many points are along a line? You can't count them. You could try and say you can count the points where they cross through nice corners or they have nice ordered pairs, but every point in between, every decimal and every fraction and every square root value that you can think of would also be a solution that is along that line. Okay? And so our last system is a parallel system, and so I would have my two lines that are parallel. And remember, to have solutions, right, they have to touch somewhere, but parallel lines will never touch. Hence why they have no solution, because they never touch. And so we're going to look at three examples here today. Again, reviewing what we talked about the Friday before on solving by substitution and reinforcing these 3 points of how we see the number of solutions come out in these problems. And so example 1, a consistent independent system. And so in a consistent independent system, remember that's two lines that are going to cross something like this and like this, right? And so we need to use substitution. And so I'm going to take what I see here. I have y equals 1/2 x. I'm going to take all of this and substitute it into that y there. And so when I rewrite this problem, it's going to be 3x minus 4 times 1/2 x equals the 10. And I can hear some of you now from all the way in Sumter County, because I know what you're saying. There's a fraction in this problem. I don't know how to do it. You can do fractions. Come on, y'all. So we're going to take this -4 and we're going to multiply it to what we have inside. So what is -4 times 1/2? What's 1/2 of -4? It's -2. And don't forget, we still have that x. So 3x minus 2x is equal to 10. And so then we'll just subtract these. 3x minus 2x is x. And so x is equal to 10. So as I start to write my ordered pair, it's going to be 10, comma, something, because the x is 10. But I need to take this value and plug it back into one of the originals. I can plug it into the first, I can plug it into the second. It doesn't matter which one I plug it into, but I got to plug it in somewhere. The second one is better. So I'm going to get y equals 1/2 times the 10. And what is half of 10? Half of 10 is 5. And so the y is equal to 5. And so this solution, where these two lines cross, is at the order pair 10, 5. Okay? Let's look at example 2, a consistent dependent system. Now, when you're doing these problems, they're not going to tell you that the problem is consistent dependent or consistent independent. You're going to have to figure that out on your own. I'm giving you the titles here so you know, hey, this is the type of problem that it is. So that way you can reference back in your notes later on. Okay? And so we've got 2x minus 7y is equal to 28, and y is equal to 2 sevenths x minus 4. And again, I can still hear you talking about, oh my God, there's a fraction in this problem. You're okay. Don't panic. We're going to take all of this, and we're going to substitute it again in for the y, because that's what we're equal to. It says y equals 2 sevenths x minus 4. And again, go back to what we talked about that Friday before. 4 quarters equals $1, right? I'm substituting one for the other. And so we get that 2x minus 7. Substituting in what I've got here in this box, 2 sevenths x minus 4. And that's equal to the 28. Okay? So now we're going to distribute the negative 7. So the negative 7 times 2 sevenths x and negative 7 times negative 4. And so I'm going to get the 2x. Negative 7 times 2 sevenths x. The 7's will cancel, and I'm going to get negative 2x. So I'm going to get negative 2x. And negative 7 times negative 4 is a positive 28. And all that is still equal to 28. And then my next line, I've got that 2x minus 2x. Well, 2x minus 2x is 0x, so it's just 0. So all of this part, all of this part cancels. And we're left with that 28 is equal to 28. Now, if you go back to solving equations and solving inequalities, if we got the variables to completely cancel, we would then judge the statement as being true or false. And we do the same here. 28 equals 28 is a true statement because a number is equal to itself. Now, when we got a true statement in those one variable problems, we would say that the answer was all real numbers because the entire number line was going to be able to plug in for that variable, and it doesn't matter what I plug in. Now, that's kind of true here, but remember, it's not every ordered pair along the graph. Remember, it's that these two lines are going to be the same line on the coordinate plane, right? You got our two lines that are the same line. And if I graph where it's actually going to be, the y-intercept is at negative 4 because 2 sevenths x minus 4, and this would have a slope of 2 sevenths. And so every point along this line is a solution, right? And so what is the solution to what? So again, if the question is what is the solution or what are the solutions, the answer is the equation of the line. Y equals 2 sevenths x minus 4. Okay, so again, if the question is what is or what are the solutions, the answer in this type problem is the equation of the line. It could be in standard form, it could be in slope-intercept form, it doesn't matter which one. Now, if the question is how many solutions, well, how many solutions are along this line? So again, if the question is how many solutions, the answer here is infinitely many solutions. So again, pay attention to what the question is asking you if it's asking you for what is the solution or how many solutions, because that does make a difference in what you'll give for your answer. Okay? Let's look at example 3, inconsistent systems. Remember that inconsistent systems are parallel systems. And so we're going to have two lines that are parallel and they're never going to touch, right? And so let's see what happens in this problem to show us that it's going to be parallel. Well, in this one, I've got them both set equal to y, so I can take all of this and substitute for that y there. So I'm going to get 3/4 x plus 5 is equal to 3/4 x minus 2. And so we'll subtract the 3/4 x from both sides to get them on the same side. This cancels, but this also cancels. And so I'm going to get that 5 is equal to negative 2. The variables all went away again. And again, if the variables all go away and all I've got is a number equals a number, I judge the statement as being true or false at that point. This is a false statement. And just like when we did it with one variable problems, if I get a false statement, the answer is always no solution. And that's true for what is the solution. That's true for how many solutions, right? Because what is the solution? There is no solution. And how many solutions are there? There are no solutions. 0. There are no solutions, right? And so that's it with this section. Again, what I want you to get out of this is understanding the cases of what happens to find these solutions. And so that's what you're going to be looking at in your assignment today on your 2 Khan Academy exercises. You're going to have one that is going to be asking you to solve the systems by substitution. Do your work, right? Obviously, with Khan Academy, the answers go in, right? But you need to know how to use substitution because it is one of the required methods in our standards. And then the other assignment in Khan Academy will be asking about numbers of solutions. And so you'll need to figure out, based on the equations and solving it out, how many solutions happen. Is there going to be one solution? Is there going to be no solution, or is there going to be infinitely many solutions? There are no other cases when we're talking about 2 lines on the coordinate plane. Just a reminder that my office hours are a little different today and tomorrow. So if you're watching this video on Monday, my office hours will be 10 to 12 and 3 to 4. So again, 10 to 12 for 2 hours there, and then 3 to 4. I've got something going on in the early afternoon that I cannot be available from about 12:30 to about 2:30. So again, 10 to 12, and then 3 to 4 tomorrow for today, and then Tuesday I'll be available from 3 to 6 because I will be at the school cleaning out my room, and so I need to have that time available for that. So again, if you have any questions, hit me up. You know you can hit me by email anytime, and get your stuff done because this is the last week. Let's push through and get this done. So y'all have a great day. Stay safe, stay home, and do what you need to do to be healthy. Y'all have a great day.